Hello, in this next series of playlists, there will be two, and then with a final wrap-up video, we're going to discuss the overlay suitability analysis method that we're going to be using for our pollinator project. Now, a lot of you have been asking, well, how do I start such a complicated project? How do I know what layers to include? So one of the things that I tend to do is I actually just flowchart all this stuff out. And I will start at the end here. So at the end, with this yellow rectangle, it says final habitat composite. So I know at the end of the day, I want a final habitat suitability. To do that, based on our needs, we know there are two kinds of habitat that could be in the same place or different places for pollinators, particularly foraging and nesting. So before I do a final overall suitability analysis, I have to back up and I have to have a composite foraging habitat and a composite nesting habitat. And then I go kind of from there back to the beginning. And so how do I know what is good for foraging? Well, I create a wish list. Now, not everything makes the final flow chart from my wish list, but I list things like vegetation, water access are kind of the two big ones. Well, we don't really have high resolution, high quality vegetation data, but I do know that from our data collection there are particular kinds of land uses that are more likely or more able to be designed for pollinators. And so I pick out those kinds of land uses. So in this case, I'm going to use two shapefiles, the land use and lakes and rivers for foraging habitat. And then I kind of focus on just this model. How do I get these two layers to a composite of land use and water? Well, we know flight distances. So if I'm going to overlay and rank and score, the closer to water the pollinators can be, the higher the score. And so I need to do some sort of buffer, but we have different flight distances, so I need multiple buffers. That generates a buffer file. I'll rank and score that buffer file. I'll have a scored water buffer file, and then I have to merge it or union or just intersect common language here, not necessarily GIS terminology, with my land uses. So then I go back and it's like, well, how do I get those land uses? Well, I select by attribute. I have those selected uses and I rank and score them. And I have these scores and I can put them together, and that's my composite. Same with the nesting habitat. So again, we have certain soils or slopes or aspects. We could have all kinds of criteria, but for our purposes, there's kind of two big ones, and we are going to kind of lump some of them together. So we're going to start with slope and aspect down here on the bottom, and we have to calculate our aspects, get the aspects, and then you may not know this, but a lot of the slope and aspect stuff comes in a raster file, so we'll have to convert that to a shape file. And then we'll have to rank and score, and then we'll have to union that with our land uses. Now, land uses, my rationale for selecting certain kinds of land uses are, how are they developed? Do they cover most of the lot like big industrial and commercial spaces do? They tend to cover up in how they're constructed. They use heavy equipment, so it destroys soil profiles. So for ground nesting bees, it wouldn't be good. A lot of industrial don't do creative landscaping. So I would, kind of select them as a lower ranking, and then likewise, parks and open space and existing conservation areas could easily be tweaked with their planting palette to create pollinator habitat. So again, land uses is going to serve as a kind of an aggregate variable here, again, for other variables that we just don't have GIS data for, or it's too complex to put into our model. And so we just do the same thing, select by attribute, rank and score them, union them, and we have a composite nesting habitat. Now, depending on computer processing power, this may be our last step, is we have a composite nesting habitat and a composite foraging habitat. However, I want you to at least try to put these two together to create a final habitat composite twice. So just, if it succeeds the first time, you're done. But if it doesn't succeed the first time, try a second time, and if it doesn't work the second time, inform me, and we'll kind of just stop at the foraging and stop at the nesting. So that's where I start a lot of these projects. Flowchart it out. I just kind of like, what's my end goal? Define my end goal, define the goals and objectives. And then I think, well, what do I need to get there? What kind of data? If I don't have that data, what other data could serve as a substitute to that? And I just kind of build out a couple of drafts of mock flowcharts, and then I end up with something like this. This is the spreadsheet that kind of goes into that. So how do you rank them? How do you know what attributes are? Well, I create a spreadsheet next. So once I have my flowchart, I go back and I say, okay, I have a submodel of foraging and a submodel of nesting. Here are my variables. Here's a kind of a common language description of what I'm looking for in those variables. And then I have the actual attributes that are in the GIS data. So I do a little data sleuthing. I look at metadata. I look at how I'm going to process stuff, whether it's a multiple ring buffer up here on the rivers and lakes, what are my distances, and I just write all this out. And then at the end, I attach my scores. So we're using a equal weight, so there's no kind of weighting more important than another. So we have a 4, a 3, a 2, and a 1, and then anything that doesn't fit any of these categories will obviously be a 0. So in theory, when we do a final scoring, we could have a 4 plus a 4 plus a 4 plus a 4, and that's how this will work. And so I wanted to show you that. So these are kind of the two things that will help guide everything then we do in GIS. So that concludes this video, and we'll move on to the next one. Thanks.